All right, we're dealing in 6.5. We're looking at properties of logarithms. And we have three main properties. And then I'm going to show you two skills that you're going to be tested on in our homework. So, first property, I like to think of this as the addition multiplication property, not mu-lt, multiplication property. And it states log base 10 of a plus log base 10 of b is equal to log base 10 of a times b. What up?
A question for you.
Uh-huh.
I have to take contemporary math when I go to college. Is that going to be hard for me? Like worse than what I did with you?
No. Once you get over the fact that you have to take a test, you're going to be fine.
Okay.
I don't know how to instill confidence in you. I tried for several years, but there's this. I think about it like sports, right? Doing the lesson is like sitting in a classroom and coach is going over film. Doing your homework is like going to practice, right? We're going to learn the plays, try them, drills. And then the test is your game, right? And you want to be at your best for the game. If you don't know the plays when you go to the game, that's going to be tough. But if you know the plays and you know them in and out, when you go play the game, you're just going to go play. Mm-hmm. And that's the way you need to really approach this class, right? Just go prepare yourself with practice. And so when the game day rolls around, you're going to be in really good shape. Does that make sense?
Yeah.
Okay. You'll be fine. And I'm right here. You know where I live. I'll always help you out.
Thank you.
All right. The second property is the subtraction division property. So the addition multiplication property says log A plus log B is log of A times B. Blaine, what's your best guess for the subtraction division? You got that exactly right. Good. So we have log of A over B. That's exactly right. And finally, our third property, that is the exponential property. And that states the log base 10 of a raised to some power. The exponent comes out front and becomes a multiplier, x times the log of a. All right. Logarithms are exponents. That'll never change. But when I look at property 1, the addition multiplication property, when my exponents are being added, what is the operation of the bases? So when my exponents are being added, I'm going to multiply my bases. These are inverses of each other. Remember that always. These guys are inverses of each other. So properties of logs are inverses of properties of exponents. If I divide my bases, then I subtract my exponents. And here, I have an exponent raised to another exponent. So a power raised to a power. When I have a power raised to a power, what am I doing with those? Multiplying. So power to a power, we multiply. All three of these properties are just extensions of these properties. All right. So what are we going to do with these properties? We need to expand the following. So let's say we start with a log base 3 of 7x. Yo, Josh Duncan.
Yeah.
What is the operation between 7 and x inside my argument? Multiplication. That's exactly right. And if I have multiplication in my argument, and I have to expand, right? Expand means get bigger. If I wanted to condense, I would go from 2 down to 1, but when I expand, I'm going to go from 1 logarithm to 2 logarithms. So here, Josh, looking at that pattern for the property of logarithms, what would I have to do to rewrite this in 2 different logarithms? How would that look? What's the base? 3, good. No. That's a base, nothing to do with the argument. Yep. Good. Yes. Log base 3 of x. Really good job. That's exactly right. Perfect. Well done, young man. Good. Right? When my arguments are multiplying, I can split it into 2 logarithms that are being added. And I just want to make sure that that's super obvious for us. So, I don't know. Let's go the log of 24. That's going to give us some number. Cool. 1.38202. Name a factor pair of 24. 8 and 3. So the log of 8 close plus the log of 3 close. This should indeed work, right? Kick back with the exact same answer. And not only that, but 3 log, what? What did they do? How did they go from log base 10 of 24 to log base 10 of 3 plus 3 times log base 10 of 2? What is happening? Let's expand that out. We have log base 10 of 24, correct? Now, what are all the prime factors of 24?
One and 2, I mean 1 and 24.
1 is not prime. It's ambiguous. Okay, 2, yeah, so we got a
4 and
2 and 12. What does 12 break into?
6.
6 and
4.
2. What does 6 break into?
3.
Exactly. So these are all of the prime factors here. So we have 3 to the first times 1, 2, 2 to the third, correct? Are we okay with that? 2 times 2 times 2 is 8. 8 times 3 is 24. Is that okay? So this turns into the log of 3 times 2 cubed. Hey, yo. Gracie Fanning.
Oh, hold on.
Uh-huh. It's a really difficult question, so you're going to need all of your thinking power, okay? What is the operation between 3 to the first and 2 to the third? Really good job. A really good job. That is fantastic. How do I expand multiplication with my argument? What operation do I... Yeah, we are going to add 2 logs, right? So the log of 3 plus the log of 2 to the third. Good. So the log... Well, at least we don't have to learn anything new while this is going on. That was an eye roll sarcasm. Yeah, I'm with you too, Josh. Yeah, we're all there. Yeah. All right, here we go. Jaden, come here, bud. He's going to hate this because he has no clue. Yeah.
Oh no.
Hey, big dog, I got a question. Which property of logarithms can I use next to further expand this statement?
No.
There's your 3 properties of logarithms.
Okay.
We've already expanded multiplication into 2 logarithms. So this was being multiplied here. We have 2 logarithms. Now, what is the other rule that we can use to expand this one last step? Good. Rogan, what is it? Yes.
It's the third one.
Yeah, that third property.
Exponential.
Yeah, that 3 is my exponent, the exponential property. Yeah, it has to come out front. Bye, Jaden. Thanks for letting me annoy you. Right? Y'all see that last step? So when I'm looking at my calculator, hey calculator, when I did log base 10 of 24, it kicked back with the log base 10 of 3 plus 3 times log base 10 of 2. Right? Log base 10 of 3 and 3 times log base 10 of 2. Anybody see that?
It's the same thing.
It's the same thing. So how did this calculator go from this to this? It followed these steps, right? And used these properties. And that's it. And somebody a lot smarter than me wrote the program to calculate that. Let's do one more here. Let's go log base 5 of x to the 4th over y.
It's about as bad as when they built my house when I was redoing it.
I'm right there with you, Dodge. Except you don't have to deal with this all day. You don't have to deal with this for 5th hour. Yeah. Yeah, it's not fun. Yeah, they're scraping off the roof to replace it. Yeah, they didn't want to interrupt the learning, so they were going to wait till summer, and then.
I mean, there's not like there's a very substantial amount of time in the day after school.
Or before.
Or before. Anytime. other
Or
than-
summer.
Or
Yeah,
2
when they
weeks.
told us they were going to do that in the summer.
Yeah.
Or like literally like 9 days.
Just wait. You wait. You wait. So if they're doing this crap during a test, I'm going to walk my ass out there. And then I'm going to go, oi! Right my bad bunny, oi! And then they're going to look at me like I'm an idiot, and I'm going to go, we're taking a final. Get off my roof. And then if they say anything back, I'm going to get my shotgun, and I'm going to go, get off my lawn. You know what I mean? I'll go that guy. All right, what property do we see first?
But when I say it's me.
That's right. You're not an old man.
Subdivision.
Subtraction division. All right, so I see x to the 4th on top and a y on bottom. So our subtraction division property, we get log base 5 of what? X to the 4th. Good. Minus log base 5 of y. Good job. One more step. What do you see here, Blaine? What else can we do? Yeah, that's exactly right. I'm going to take that 4 and drag her right on out front. 4 times log base 5 of x minus log base 5 of y. We're doing it, guy. We're doing it.
What if I start like to
No, this is horrible. I totally forgot that we were recording. That's exciting.
Oh, yeah. Get the shotgun out.
Yeah, I'm gonna catch.
No, go back! I'm having fun, I can't stop right.
I'm blind. I can't smell right. That's incredible. All right, while you do that, I'm gonna speed run another one and talk about the differences. Let's go with log base. I don't know. 7. Okay, I already did 3. And then let's go with. No, that's too much work. You're doing the most, Dave. Let's just go with an x over y, but raise that bad boy to the fourth.
Would the 4 go in front of both of them?
Yeah, so what is the 4 attached to on the previous prop? Just the x. Now, what is the 4 attached to here? Both. Yeah, so I'm going to start.
So you add in front of the log, minus log, and the other one.
Oh, chicken tenders.
Yeah, I'm going to start just dealing with the exponent. Right, and it's 4 times the log of x over y. So I get 4 times log base 7 of x minus log base 7 of y. So it would be a distribution situation. So at the very bitter end, we would end up with 4 log base 7 of x minus 4 log base 7 of y.
Really fast.
Hey, I was doing that while you were writing, so don't yell at me.
No, I started when you started.
Oh. Still just cracks me up. You know that sign that used to be out in front of Miss Cornelius's room that said, "Don't forget why you started"? And my teenage brain couldn't help it turn the T into an H. So don't forget why you not started, but stop! Talk in my room! And to which I would say, better advice, right? Because, everybody has a multitude of reasons why you start. But you don't want to forget the reason why you had to run home and change your pants. I love that one. Well, then 3 weeks after I told a bunch of kids, somebody went and took a marker and turned the T into an H. Yeah, and that only lasted for 30 seconds, and then some adult took it down. Yeah, why do we have ho-hum adult? Are you done, Bradshaw? Okay. All right, so if taking one logarithm and expanding it out into multiple logarithms, that's called expansion. What do you call it when we take multiple logarithms? Yeah, we're going to condense. Yes, we're going to condensation this thing. Condense. I don't even think I'm spelling that right. The following. Hey, I said it with perfect spelling. When I said it, the spelling was perfect, but when I started writing, I don't know. I did? I trust Blaine. Blaine hasn't lied to me but 3 times.
Condense.
Okay.
Yeah.
Okay.
CONDENSE.
Fire! No, I'm brilliant. I know how smart I am. Let's go with just log base 10. Let's call it x. Let's add 3 log base 10s of y.
Yo, I thought you said log base 10.
I did.
Yeah, remember in our notes when log base 10 is just the normal log?
Yeah. So if you got a naked logarithm, it's understood to be a base of 10.
What was that?
I farted through my mouth. They're called burps, but I think it's funner to call them mouth farts.
There was one time in the notes.
Still got a teenage brain.
There was one time in the notes where you were
It's okay, we still love
you had stopped what you were doing and we were mid-writing it down and I was writing it down with you and you were like, but make sure you're actually making your exponents an exponent and not a multiplication. And I was like, Brad, he's watching me. I was like, I'll just be lazy. I know what it means. But
Don't.
Make sure you're making.
All right, what's our first step here? I want to turn this into one logarithm. So it's going to be my first.
Log
Cheers.
base.
No, which property?
Put the 3 back in. Do the exponential.
We're going to do the exponential.
Oh,
I want to handle that 3 first. Yeah, so she goes up top. So that gives us log base 10 of x plus log base 10 of y cubed. As he says. All right, now we can handle the addition multiplication to get down into 1. Final log base 10. What's going to be my argument now? X times.
Oh,
y to the third. That's exactly right. Or xy to the third. All right, cuckoo. I hope they do this to you. I didn't see the homework, but I hope they do this to you. So let's go with 1/2 natural log of x minus 1/2 natural log of y.
That's not funny.
That's not even funny.
Say sorry.
Had a hard day already, man.
Okay, let's put the exponent.
Hey, Gracie, I want you to put words behind the face that you just made so I can talk about it. Let me help you fix your face. What are you thinking, dude? Wow. Yeah. You get 2 free punches on summer after that one. Why would you say that?
First of all,
Yeah.
I was just
Gracie-
giving solutions.
Gracie Fanning's face is fine.
That's not a
Is
wiggly.
it L and
It's
N?
an L, yeah.
Yeah, that's natural log.
That's
I didn't know
natural
that.
log, which is
I hope you have to clean
backwards.
up Lou's
I don't know
pee
why
on
they
the
had to
That's
make it
L.
backwards.
That is L in cursive. Right?
It's okay. I had to ask Google when
That's-
I was
that's a
looking
cool
at
L.
the videos.
Thank you.
I'm gonna start hitting that.
Yeah, fire. Thank you, DC. Appreciate you, big dog. All right, so what's our first property?
Put the exponent.
Exponential property. So the number out front becomes the exponent. So I get the natural log of x raised to the 1/2 power minus the natural log of y raised to the 1/2 power. All right, now what property are we going to use? Subtraction division. Yeah, so now I get 1 natural log of x raised to the 1/2 divided by y raised to the 1/2. Do we have the same exponent? Yeah, so I can rewrite that as the natural log of x over y being raised to the 1/2 power. I didn't need that extra set in brackets, but I felt like it, so we're dealing with this. What is the meaning of 1/2 as a power?
Wait, is the 1/2 supposed to be inside with the x and y? Or
No, it's taking all of x and y and raising it to the 1/2 power. So x over y first, 1/2 second.
Is this an exponent for the ln or is it just times?
That is the exponent of xy inside the argument of the natural log.
So it's just a normal
Yeah.
multiplication.
So I'm afraid that you're going to run into Savas and you're going to get to this point right here and it's going to tell you you're wrong because we didn't put it in this form. So how can we rewrite that as a radical? It becomes, yeah, good, natural log of the square root of x over y. And that is most likely what you'll end up running across. So if you get a tough one, which I doubt you will, that's mostly college algebra stuff is when they mix them.
Oh, so
Just giving you a heads up what's going to happen in a year from now. You'll go, oh, that's it. And I'll go, yep. And you're going to go, great. And you're going to go to work. Yeah, you are. Wyatt, don't sell yourself short, big dog. You got this.
Wyatt, join the class.
I'm like,
Wyatt, join the class.
You're not wrong.
I need it for my associate's degree, and
That's fair.
I'm working.
So you're going to limit your future is what you're saying? You're ready to limit your future?
No, but I have to get my associate's degree next year.
So you just want to be home.
I guess so. I guess so.
So you just want to work at Walmart? Is what you're
I
saying?
guess. Have a nice time when I put lead in this town's water. I don't think I can legally say that.
He's been saying that for years.
Yeah, that is true.
So you want to poison everyone in town?
No.
So what you're saying
That was a mistake.
me committing suicide is basically illegal, but you putting it.
Hey, listen, this is being recorded here. Summer Bradshaw, who lives at 1207 in Chestnut Avenue.
Is that Z or 2?
That's a Z.
Dude, I don't know.
That's a
Put
Z.
the line in it.
That is a Z.
You put the line in it.
Have you guys seen some, like, he just puts lines in a bunch of stuff.
No, sevens and Z's. Just sevens and Z's.
Look at your O right now. It's got lines in it.
That's lazy stuff.
Exactly.
No, that Z is purposeful. That's just lazy work.
How do I know the difference?
Purposeful and lazy. Well, listen, Linda. Listen when I say it out loud. Log base 3 of x minus log base. Stop talking.
You were on about the recording.
You've got. Hey, you know what? I'm gonna give you the full life lesson that I give my wife and my daughter on a daily basis, which is when the man is talking, the women. Oh yeah, I know, and I'm teaching online people life lessons as well.
Being recorded, by the way.
Anywho. All right, so let me teach you a real quick shortcut. Y'all ready?
Sure.
And in fact, I need some random numbers to go with it. So let's do this. Let's call that a -2. Let's call that a +5.
Yo, I ain't got no.
I know, me too. Rewrite it. Rewrite that while I go through this real quick. If, and don't write this next part down, but understand what I'm about to say. We have log A minus log B, right? Easy. So, if I use the exponential property, what is this value? What is that number right there?
-1.
-1. So I could rewrite this as log A plus log B to the negative first. And easy. Stop interrupting and let me finish, Linda. So what happens with a negative exponent? We go down. Yes. So this then becomes log A plus
Log
1 over B to the first. And now we would multiply A times 1 over B, and we get the log of A over B. Now, we already knew that, but this idea of turning negatives into a positive with the exponent becoming negative is valuable. So what am I saying? If I have a negative in front of a logarithm, where did the argument end up? The numerator or denominator? The denominator. So if I have subtraction, the following argument is in the denominator. So watch carefully as to how I speed run this bad boy. The exponent is a multiplier in front. I don't have one, so I have x to the first on top because it's positive. This y, is it a positive or a negative log base 3 of y? It's a -2, so that means I have y squared in the denominator because it was negative. The 5 log base 3 of z, is it positive or negative? So it's going to end up on top, z with an exponent of 5. And on the denominator, because this log is negative, that w is going to go down to the bottom with an exponent of 1.
Nice.
That, my friends, is how you speedrun. You're itching a lot there, Mia. What's going on?
I don't know. I think I'm like growing a
She's
beard.
like on the
You're growing a beard, or are you having
I think